Hello everyone, my name is Tej and today we will be looking at the sorting technique called bubble sort. So the name bubble sort comes from the natural phenomenon of when you boil water on a stove or any place else, bubbles tend to come up to the surface after some time. So in a similar way, in this sorting technique, as you can see this unsorted array right now, the larger numbers in this like 4, 5, 3 tend to come up to their rightmost side. For example, after the first iteration, 5 will come to this side, the rightmost side, then 4 will come to the second rightmost side, and similarly. So in a way we can say that the lower elements are coming to the higher places right now. So I'll first show you the dry run for this algorithm. So taking this array first, 4, 1, 5, 2, 3. In this technique, basically swapping takes place in every iteration. In every moment, some type of swapping or something takes place. So first of all, these two elements will be swapped. So if it will check that if this element is bigger than this element, then only swap, else don't swap. So 4 is bigger than 1. So the new array will be 1, 4, 5, 2, 3. Now it will check if these two elements. So 4 is not bigger than 5. So it will not swap. 1, 4, 5, 2, 3, it will remain the same. Then after that, it will check these two elements. Is 5 greater than 2? Obviously. So 1, 4, 2, 5, 3. Then it will check for these two elements. 1, 4, 2, 3, 5. As you can see now, after the first iteration, that is first iteration, 5, that is the largest number in this array, is in the rightmost position at its correct position where it should be, as we are sorting in the ascending order. So now coming down to the second iteration, now this is our new array now. So 1, 4, 2, 3, 5. These two will be checked first. 1 is not greater than 4, it will remain the same. 1, 4, 2, 3, 5. Then it will check this. 4 is greater than 2. So 1, 2, 4, 3, 5. Then it will check this. 4 is greater than 3. So 1, 2, 3, 4, 5. So as you can see, the array is currently sorted, but bubble sort will still check for other iterations as well, because that's how bubble sort works. So coming to the third iteration, this is our new array. So 1, 2, 3, 4, 5. These two will be checked first. 1 is not greater than 2, so it will remain the same. 1, 2, 3, 4, 5. And at this point, we know that 4 and 5 are in their correct position. So we will only check till here, till this point. So 1 and 2, this has been sorted. So now it will check for this. 2 is not greater than 3, so it will not sort. 1, 2, 3, 4, 5. So we now know that 3, 4 and 5 are all in their correct position. Now coming to the fourth and last iteration. This is the new array. 1, 2, 3, 4, 5. We will check for these two again. 1 is not greater than 2, so it will not swap. 1, 2, 3, 4, 5. And we only had to check for these two, and we can see that 2 is also now in the correct position where it should be. So now all these elements are in the correct position, and we know that only this element is remaining. So obviously it would automatically be in the correct position, right? So yeah, so only 4 iterations. If 5 elements are there in the array, 4 iterations, that is n minus 1 iterations are required. So now coming to the pseudocode for this question. Pseudocode. So what happens in the algorithm is that first we define an array. Okay, array 4, 1, 5, 2, 3, and n as the length of the array. So now we start an outer for loop starting from I equals to 0. Just a second. Starting from I equals to 0 till n minus 1, as I told you here. So only 4 iterations are required when 5 elements are there in the array, because the last element will automatically be in the correct position. So we don't have to check for that. Why waste time on such unnecessary thing? So now for the inner for loop, it will go from for j equals to 0 till n minus I minus 1. Now this is the most important part of the bubble sort basically. So as we can see here, n minus I minus 1 times we have checked for the first iteration where I equals to 0. So n minus I minus 1 would be equal to 5 minus 0 minus 1. That is 5 minus 1 equals to 4. So basically we have checked 4 times, right? And for similarly for others as well. So n minus I minus 1 is the most important part. Now we will do the swapping and check if the j element is greater than or less than to the j plus 1 element. So if array element j is greater than array element j plus 1, swap j and j plus 1. So that's pretty much about it, So in the end, we will just print the array. So this basically sums up everything that happens in bubble sort. There is one more outlier case, I should say, where what if the array is already sorted? Then it is no use for the algorithm to run so many times, as the time complexity is O(n) square, which is a quite big time complexity. So we can set a special test case for that, which I'll show you in the code that I'm about to show you now. So we have first initialized the array here as 4, 1, 5, 2, 3, and n is the length of the array. So now we will start with the outer for loop, which goes from I equals to 0 till I less than n minus 1, I till n minus 1, I plus plus. And the inner for loop will go from j equals to 0 till j less than n minus I minus 1, as I explained in the pseudocode. So then it will check that if array j is greater than array j plus 1. So the j element for the first iteration would be 4, and j plus 1 element would be 4 plus 1. So it will check if 4 plus 1 is 4 is greater than 1. So in this case, yes, 4 is greater than 1. So it will swap the values. So in temp equals to array j, the normal swapping method that is followed. Array j equals to array j plus 1, array j plus 1 equals to temp. So the swapping here has been done now. After that, we can just simply print the array and the sorted one will be printed in front of us. Equals to 0 and n. So if I run this code now, as you can see, the sorted array has been printed now. So now that the test case, the outlier test case that I was talking about, if the array is already sorted, in that case, 1, 2, 3, 4, 5. So as you can see, this array is already sorted. So in this case, bubble sort should not do the regular thing that it is currently doing, like going through O(n) square times. It will waste a lot of time. So in that case, we can just initialize a Boolean variable in here called swapped and initialize it as false. So we can say that if any type of swapping is done, we will set swapped equals to true. Okay. So in the first case, if the previous array was taken 4, 1, 5, 2, 3, in the very first case, 4 and 1 were swapped. So it would have been set to true. But in this case, 1 is not greater than 2. So it would not swap. So here we would check if swapped is still equals to false, and if it happens in the first iteration. This is important, that it should happen in the first iteration only. So because imagine if the array is already sorted 1, 2, 3, 4, 5, in the very first iteration only, we will see that 1 and 2 are not being swapped. Then what is the need for checking the others? So we can simply print here system.out.print array is already sorted. And we can just return the complete code from here and not print this part of the array because array is already sorted. So now if I run this code, it says array is already sorted because it is already sorted. So if I run the previous array for this one, it will print the correct array. So that was the code for bubble sort algorithm. Thank you for watching.